So we're talking today about working with complex numbers. So first of all, I need to know what a complex number is. Complex numbers are numbers that have an imaginary number in them. So that's all you really need to know. But before we get into like how we work with them, let's start with this problem: 3 plus 4x plus 2 minus x. Well, just combining my like terms. Well, let me get rid of my parentheses first. When I have parentheses, there's really a 1 in front of those parentheses. And if I distribute, 1 times 3 is 3. 1 times 4x is 4x. And then a positive 1 times 2 would be 2. And positive 1 times negative x would be negative x. And then I can group my like terms together. Well, 4x and negative x are like terms. And 4x minus x would be 3x. And also 3 and 2 plus 2 are like terms, so 3 plus 2 is going to be plus 5. So if I simplified this problem, I would get 3x plus 5. And looking at the problem underneath it, 3 plus 4x minus 2 minus x. So again, there's a 1 in front. Anytime I don't have that number in front of my parentheses, it's a 1. If I distribute that, 1 times 3 is 3. 1 times 4x is 4x. Negative 1 times 2 is negative 2, and negative 1 times negative x is positive x. And then I can combine my like terms together, so I have that 4x plus x, which would be 5x, and I have 3 minus 2, which would be minus 1, so the simplified form of this problem would be 5x minus 1. So moving on to part C, where I'm supposed to multiply these, or FOIL. So I have 3 plus 4x times 2 minus x. So if I'm going to FOIL, I'm multiplying 3 times 2, which is 6. And then 3 times negative x is negative 3x. And 4x times 2 is 8x. And 4x times negative x is negative 4x squared. And if I'm looking for my like terms, this negative 3x and this positive 8x can be combined together, which gives me a positive 5x. Then I can bring down that 6, and I can bring down that minus 4x squared. And this would be my final answer. So I was able to FOIL these two pieces together. So really what we're talking about today is if instead of having an x, where we have our variables, if we had I, the imaginary number, I, the imaginary, what they call the imaginary unit. Well, if instead of x, this was an I, then my answer would really be 5 plus 3i. And if instead of x in the 3 plus 4x plus 2 minus x, if that x was again an I, then my answer would be 1 plus 5i. So having this I here doesn't change our operations on the problem. So 6 plus 5x minus 4x squared would be 6 plus 5i minus 4i squared, which is a little bit more that we can do with that one, and we're going to get to that in just a second. But essentially all we're doing is, when we're going to be working today with our problems, is we're going to be using the letter I instead of any other variable x or a or b or c. So I mentioned a few minutes ago that we are going to be working with complex numbers today. You need to know what a complex number is, and it's easy. It tells you right here. A complex number is the part a plus bi. A is the real part, and B is the imaginary part. So the reason that A is the real part is because A is just a number. And the reason that BI is the imaginary part is because B has I attached to it. So complex numbers are numbers like 3 plus 4i, 4 minus 2i, 1 minus I times the square root of 5. And each of these pieces, each of the complex numbers has a real part. So my real part is, in the first one, 3. And then the second one, it's 4. And the third one, it's 1. And these numbers also has an imaginary part, which is the 4i, the negative 2i, and the negative I times the square root of 5. So a complex number is one that's got both pieces in there. And that's what we're going to be working with today. So in the term negative 7i, or let's talk about in the term A, in part A, 9 plus 5i. Well, it tells you that 9 is the real part, and that's because 9 is just a number, so the real part is 9, and then the imaginary part is the 5, because that's the 5i. So if you're looking at part B where it says negative 7i, well, negative 7 is not going to be real. It is going to be imaginary because it has that I attached to it. So that's the only piece of this. This is just an imaginary number. So we're identifying whether a number is real, imaginary, or complex. So if you look at the number 11, 11 is going to be a real number. And the reason it's a real number is because it doesn't have an I attached to it. So the only way it can be imaginary is if it has the I, and a complex number is a combination of those. If I look at the top of the next page, I have negative 1 plus I. Well, there's two parts to this. There is the negative 1, and then there is the I. The negative 1 is going to be my real part of my number. The I is going to be the imaginary part of the number. And the whole thing, the negative 1 plus I, is a complex number. The whole thing is considered a complex number because it has a real part and it has an imaginary part. So it's got both. So when we get into the rest of what we're doing today, which is adding and subtracting complex numbers, the way I add and subtract complex numbers, like negative 7 plus 2i plus 5 minus 11i, is the same way that I added and subtracted earlier with x. So anytime I have parentheses, remember there is a 1 in front of those. 1 times negative 7 is negative 7. 1 times 2i is 2i. 1 times 5 is 5. And 1 times negative 11 is negative 11i. Sorry, 1 times negative 11i is negative 11i. I can combine my like terms. Well, my plus 2i and my minus 11i are like terms because they both have I attached to them. And 2 minus 11 is going to be negative 9i. I can also combine my negative 7 with my positive 5, which is going to give me a negative 2. So my answer to my problem is negative 2 minus 9i. So moving on to the next one, 18 plus 27i minus 2 plus 3i. Again, there's a 1 in front there. 1 times 18 is 18. 1 times 27i, is 27i. Negative 1 times 2 is negative 2. Negative 1 times 3i is negative 3i. And I'm looking for my like terms. Well, I have an 18 and a minus 2 that are like terms. If I combine those, I'm going to get a 16. And then I have a plus 27i and a minus 3i. And 27 minus 3i would be 24i, and it would be positive. So my final answer to this problem would be 16 plus 24i. So hopefully you can see that for these problems, when I'm adding and subtracting, it's no different than when I had x earlier. And that's what makes these really easy to work with, is that it's just like having x or a or b or c or y or whatever variable you would have. So now you're going to answer questions 7 and 8, and they're going to pop up over on the right-hand side for you to answer those. So now we're going to talk about how to multiply complex numbers. And the multiplication of complex numbers gets a little bit interesting because of one thing. So we need to review something that we learned when we talked about imaginary numbers the very first day. And that is, first of all, that we know that I is equal to the square root of negative 1. I squared is equal to negative 1. And I need to explain that. So I'm going to move over here to the side. You don't necessarily have to write this down unless you just want to. But I need to talk about why this I squared is equal to negative 1. So let's start with I, which we know is the square root of negative 1. Well, if I wanted to square that, then on the left side, because I can do whatever I want as long as I do it to both sides of the equation, on the left side I would have my I squared. And on the right side, well, if I have the square, I have the square root of -1 squared, then remember squares and square roots cancel each other out. So I'm really just left with -1. That is why I squared over here on the left is equal to -1. So the next step is that I to the third is equal to -I. So we're going to talk about y. So if we think about I to the third is the same thing as I to the second times I to the first. Because when I multiply, I add my exponents. And we just went over the fact that I to the second is really -1. So this is actually -1 times I. And -1 times I is going to be -I. So that is where our -I came from that we had over here. All right, our last one that we need to know is we need to know that I to the fourth equals +1. We're going to talk about y. Of course, we're going to talk about y. Why would we leave that out? So if I have I to the fourth, well, I to the fourth is really I squared times I squared. Because when I multiply again, I add my exponents. That 2 plus 2 is going to give me 4. And we talked about a second ago that I squared is really -1. And again, I squared is really -1. So I have -1 times -1. And a -1 times a -1 is a +1. So that is where this I to the fourth equals 1 comes from. So what's unique about our imaginary number I, or our lateral number I, is that this forms a pattern and it continues to repeat over and over and over and over again. So if I were to keep going, I to the fifth is going to be the same thing as the square root of -1. And then I to the sixth is going to be -1. And I to the seventh is going to be -I. And I to the eighth is going to be 1. And then it starts back over. I to the ninth equals the square root of -1. And it goes on and on and on and on. And hopefully you can see that these four right here, these 4 pieces, form a pattern where these answers end up repeating. So notice square root of -1, -1, -I, 1. Square root of -1, -1, -I, 1. Square root of -1, then it would be -1, I, 1. It would just keep repeating over and over and over and over again. Okay, I say all of this to really say that today you have to make sure you know these 2 pieces. More than anything else, these 2 pieces are your most important parts. They're going to come in handy. So let's look at our multiplication. I'm going to talk you through the example that they worked out because I think they did a really good job with it, and we're going to talk about what they did. So we have 4 plus 9i times 6 minus 2i. So I'm going to FOIL this. Well, 4 times 6 is going to give me 24. That's my first. And then outer, 4 times -2i. That's where the -8i comes from. And then inner, 9i times 6 is the +54i. And last, 9i times -2i is where the -18i squared comes from. So here's what's important, is that if you notice, you have right here an I squared. And we just over here proved that I squared was really -1. So that means whenever I have this I squared, I have to replace it with a -1. And that changes my problem up a little bit, makes it a little bit more complicated. So I have really 24 minus 8i plus 54i, and then instead of -18 times -1, I actually have a +18. And then I can look for my stuff that I can combine together, my like terms. Well, I had a 24 and a +18. That's where the 42 comes from. And then we also had a -8i and a positive 54i, and if you combine those, that is where that 46i comes from. So this is, the multiplication is going to be the tricky part here. All right, let's look at the next one. So we have negative 3 plus 7i times 7 plus 4i. So I'm going to FOIL this. So negative 3 times 7 is negative 21. Negative 3 times 4i is negative 12i. 12i times 7 is going to be 84i. And 12i times 4i is going to be plus 48i squared. And the thing that we just talked about is that when I have this I squared, it really becomes a negative 1. So now my problem looks a little bit better, and it's actually negative 21 minus 12i plus 84i, and then minus 48, because a positive 48, times a negative 1 is going to give you that negative 48. Well, now I can combine my like terms. So one set of like terms is my negative 21 and my negative 48, which together is going to give me negative 69. And then I have my negative 12i plus my 84i, which would be a positive 72i. So this would be my final answer. So hopefully you're thinking, man, this really isn't too bad. And really and truly, this is all you're learning today. We're not doing anything else with it. So don't be like, oh my gosh, it's going to get so much harder. No, it's really not. So we're going to look at problem 10. Well, I have 6 minus 5i times 3 minus 10i. So just kind of practice this. So FOIL, I'm going to multiply 6 times 3, which is 18. And then first outside, 6 times negative 10 would be negative 60i. Inside, negative 5i times 3 would be negative 15i. And then last, my negative 5i times negative 10i would be a positive, because a negative times a negative is positive, 50i squared. But we know that I squared is really negative 1. So if I make this look a little bit better, then I have 18 minus 60i minus 15i, and then a positive 50 times a negative 1 is a negative 50. And I need to combine my like terms. Well, my like terms would be my 18 and my minus 50, which is going to give me negative 32 when I combine those. And I also have my negative 60i and my negative 15i, which I can combine together, and that gives me a negative 75i. So this negative 32 minus 75i would be my final answer. Also going to work out problem 11, and then you're going to have a couple you're going to have to do on your own in just a minute as well. So I have 8 plus 15i times 11 plus I, so I'm going to FOIL this or distribute it. So 8 times 11i is going to be 88, and then 8 times I is 8i, and 15 times 11i is going to be 165i. And then 15i times I is going to be 15i squared. But recall that I squared is really negative 1. So I can rewrite this as 88 plus 8i plus 165i minus 15, because a positive 15 times a negative 1 is a negative 15. And then I need to combine my like terms. Well, I have an 88 and a minus 15. 88 minus 15 is going to be positive 63. So when I combine those two together, and then I have an 8i and a plus 165i. And 8 plus 165 is 173i. So that's my final answer. All right, we are now going to go back and look at question number 9. The question says, is a plus bi times a minus bi a real number or an imaginary number? So we are going to FOIL this. So if I FOIL a plus bi, well, if I do my first, a times a is a squared. Then I do my outside. A times negative bi would be negative abi. Then I do my inside, and that would be my bi times a, which is a plus. When we write these things with multiple variables, we usually write them in alphabetical order, just because we're math people and we like things to be in order. It makes sense to us. And then plus bi times negative bi would be a negative b squared I squared. But hopefully you remember, oh yeah, that I squared is actually negative 1. So then I can simplify this a little bit. I can rewrite it again at least and get rid of some of this. So I have a squared minus abi plus abi. And then a negative b squared times a negative 1 is a positive b squared. So now if I look at this, well, I have some like terms. I have this negative abi and this positive abi, and they are actually going to cancel each other out because one is negative and one is positive, and so they're opposites of each other. So I am just left with a squared plus b squared. Well, the question is this a real number or an imaginary number? Or would it be a complex number? Well, the only way it's an imaginary number or a complex number is if there's an I there. Since it's neither, since we're just left with a squared plus b squared, this is a real number. Because both a and b were originally real numbers, that's what they told us. But since we were just squaring them, they're still real. Remember, the only way for it to be an imaginary number is for it to have an I attached to it. And there was no I attached to it. So if there's no I, it's not imaginary. We can rule that out. So if you jump over to page 197, that's where you're going to find your homework for tonight. So your homework is going to be 3 through 18, and then problems 23 and 24. Again, if you're doing the homework online, then those problems are already assigned to you. You don't have to skip anything because I've already omitted all of the problems that you don't need to do. So this assignment is going to be due on Wednesday. So all these problems are going to be due on Wednesday. Make sure if you're doing it on the online portal that you are doing your work on paper, and because you're going to have to turn that in.